we're going to talk a little bit about applications for Fluxgate sensors. Compassing is certainly one of them. Just a basic north, south, east, west application. Orientation. This is more like a 3D, three-dimensional compass. Those applications are generally paired with accelerometer sensors. Attitude and positioning. So positioning of, say, a satellite with relation to the Earth, so it can position itself and read a signal or pinpoint on a certain position. Magnetometers are certainly used in those applications. Ranging and signature measurement. So measuring the magnetic signatures of vessels underwater, figuring out how far they are away, things like that. Magnetometers are used in those applications. Magnetic anomaly detection, buried metal ordnances, finding landmines, things like that. Magnetic roll detection. So if you've got something that's moving, a vehicle that's spinning, and you want to determine the spin rate or the orientation, the position around the circumference that you're spinning, then magnetometers can be used for those applications as well. So this first application, we're going to talk about energy exploration. This is a directional sensor, and see on the bottom of the slide, there's a directional instrument. On the right-hand side, there's a little orange, piece on it. That's actually a shield, and underneath there are the actual magnetometer sensors. This directional instrument is mounted inside a borehole assembly, and that is the drill bit essentially for an oil and gas exploration or geothermal exploration operation where you're drilling for gas, oil, or geothermal energy. These boreholes that they don't just go straight down anymore. They go down, and in this particular slide, we've got a diagram of this borehole assembly. And as you can see, they're planning to go down, drill down to about 2,800 feet. And then by about 3,000 feet, at 2,800 feet, they're going to be vertical. And at 3,000 feet, they want to be horizontal. And so to do that, you need a directional instrument that will tell you, what your orientation is inside the borehole, so you can guide and drill that borehole properly and get it into the zone that you want to get it into the zone of interest, basically. So this is a very common use for a magnetometer. In this instance, the magnetometer is paired with a 3-axis accelerometer system, and that gives you your 3D compass. The next application we're talking about is navigation, and this would be an inertial measurement unit. And these are sensors that are very common. They're used in almost any kind of vehicle that flies or on land or glides through the water. These are 9-axis sensors, so they have 3-axis accelerometers, 3-axis gyros, and a 3-axis magnetometer system. And this basically guides all these types of big vessels and other types of large ships and things. So the next application are towed arrays, and these are used for surveillance and for surveying. And these two pictures are pictures of towed arrays. The one on the left, the blue one, is you can see it up close pretty well. It's a flexible sort of clear hose, and you can see that there's instruments inside there, and inside there would be a magnetometer sensor along with other sensors. And so the first application here would be surveying. The picture on the bottom you see is the ship, and it's got a tether on the back, and it's towing an array on the sea bottom, possibly magnetically mapping the seafloor for an oil and gas exploration. It could be also mapping the seafloor with regard to structural integrity, and this would be an application for renewable energy. If you want to place a wind farm out on the seabed, you have to figure out exactly where you're going to place these large devices that are going to be heavy and need to be structurally sound. So surveying is one of the pretty common uses for magnetometers. The picture up top, you can see a ship actually has got 20 or 30 or so of these arrays out there. The next towed array application is surveillance. The submarines tow arrays, and they use them for listening. And they want to listen and figure out if there are other vessels in the area, possibly even identify them by their magnetic signature if they can. magnetometers in these types of tilt arrays are generally used to orient or figure out where the information from other sensors comes from. In this case, they have geophones on these arrays, and the geophone can hear some activity, but it can't tell exactly in what orient where it came from. And so the magnetometer helps them determine the heading of whatever sensory input they're receiving. Attitude and satellite navigation. So satellites, of course, they have to align themselves with the Earth to position themselves in specific, very, very precise ways, so they can pinpoint positions on the Earth and take pictures or receive signals, things like that. And magnetometers are used in these applications to align the satellite with relative to the Earth's magnetic field. And this allows it to do attitude control. There's a process called momentum dumping that the satellite aligns itself, and these inertial wheels sort of correct its attitude and correct its orbit. Okay, so that's our presentation. I'd like to thank everybody for attending.